Alrighty, welcome back to 105. So it is the last lecture of actual valid content. So we are going to be searching, if you could call it something that's, something that's challenging. So for searching, this is a very common operation. When you have a lot of data, you commonly need to search for something. So previously, we searched for nodes in the linked list. Today, we will again go back to focus on arrays. So what we want to do, the entire problem we will be addressing in this lecture is, given an array, we want to find the index of the first occurrence of the value in an array. And if it's not found, just simply return a -1. So we've all probably can figure out how to do this based off what we already know. So if we give it a fancy name, the first algorithm for searching is called linear search. So you just iterate through the array, starting at the first element and then going on until you find it, or it is not present in the array. So we can make our code really, really compact that if we find a match, just return the current index and that is it. So if we were to write a linear search to search for, in this case, the first occurrence of this int value in this array, well, it should be the same thing we've been doing all the other times. We just want to iterate through the array. So we'd have for int I equals 0, I is less than the array length, plus I. And then what we're looking to do is to find that value in that array. So if val is equal to array at index I, that means we have found it at this index and we can simply return I. Otherwise, if we make it through all of the array and we don't go into that if conditional, then we won't return anything. We'll make it through the end of the for loop, and then at the end of the for loop we'll return -1. That means it is not found. So if our test program is this, so an array is this, we have our array length macro, and we're searching for the number 6. Looking through this, it looks like that value 6 should be at index 6, right? So let's compile this, make sure it works. And then we can see, hey, yeah, we found the number 6 at index 6. And we also check if the index is -1, we'll go ahead and return it, it's not found. So say we're looking for, I don't know, the number 2. If we're looking for the number 2, it doesn't look like it's in there to me. If I run it, boom, 2's not found. Nothing that new, nothing that exciting, but any questions about this? Should be fairly straightforward. If we give this to you on the final exam, it is a gift. So likely things are not going to be all that simple. So that was our first. So there's our implementation, so we can have it. Not much of an implementation, nothing aside from returning an index. It is nothing new. So if we want to search sorted data, things are a bit easier for us. So if we want to find the minimum or maximum value in an array, right, we'd have to go through every individual element and check, hey, is this value less than what I've seen before? Okay, then it's the minimum. Or if it's a maximum, is this value greater than the max I saw before? Okay, now this is the maximum. But things are a bit easier if you're looking in a sorted array. So assuming the array is sorted in ascending value, then how do I find the minimum value? Yeah, it's the first element, right? I don't have to search for anything if it's in sorted order, where the lowest value is first and the greatest value is last. Well, then the minimum value is just the first index. The maximum value is the last index. Same way if it was in descending order, just changes what is first and what is last. So if we are searching and the data is sorted, well, we can actually make things a whole lot more efficient. So we can check the midpoint, so check the middle of the array, and we can cut our search in half each time, assuming we have no idea where the value is. So if the array is in sorted order and you're looking for a value, just check the middle value. If that middle value is greater than what you're currently looking for, then you know the value must be in the left half of the array because, again, it's sorted. If the middle value is less than the value we're looking for, we need to search the right half of the array. And we do this, we cut the array, what we're searching, in half every single time. We can keep searching while there's valid array bounds, or we find the value. And this sorting algorithm is called binary search because, well, we are checking a value and we are going through one of two options. So let's try to implement it. So anyone want to help me if I'm trying to implement binary search? So again, I'm given an array like before, an array length and a value. But now I know that the array itself is sorted. So how would I write the code to actually go ahead and search for the value in the array? Yep.
If it's sorted, you can divide it into a number and see if the value is greater or less, and then take the other half.
Yeah, so I want to check the middle value. How do I check the middle value? Array length divided by 2. So let's do array length divide by 2. Uh-huh.
Yeah, and you just check if that value is, if the value that we're searching for is greater or lesser than. And if it's less, then we take the first half of the array, and we just use the loop to like do this again until we find the value. Or if it's like greater than, we take the half that's like bigger than that, and we just keep using the loop, keep dividing the array in half until that's.
Yeah, but that's a lot of steps. I have to program it in C, right? Yeah. Oh. Yeah. Yeah. Yeah, so then it's in the left half. Recursively. Whoa. Okay, yeah, we could do it recursively. That's usually not the first one people go through, but that's good this year. We're doing recursively first. What about if I didn't want to do it recursively? Yeah. While the value does not equal. Have to have a variable. Okay, yeah.
You can have two variables, one corresponding to the first value of the array and the one corresponding to the maximum value of the array. If the value that we're trying to find is less than array length minus 1, we'll just change the top to array length divided by 2. And if it's greater, then we'll just change the bottom to array length divided by 2. And now we've divided our array into 2, and we keep doing that to find the value.
So if we do array length divided by 2, we might not want to do that. I think you're on the right track if we have two variables keeping track of like what our minimum index is and what our maximum index is, right? So I could do that. So initially, if I create a low index, it's probably 0. My high index is probably array minus 1. And then while, I'll put it in, I'll write that for now. And get rid of this. Wait, what's my error here? Oh, whoops, array length. All right, so now in here, let's worry about the conditional in a bit. So I want to check the middle value, right? So middle value, how do I get the middle index? Yeah. Yeah, high plus low. So mid is high plus, whoops, not might. High plus low divided by 2. All right, so that's my middle index. So the middle value is array at mid. So there's a few things that might be true here. If we're looking, comparing to mid, array.mid, what probably is the easiest one that we care about most? Or the easiest to handle? When it's what? Yeah, when they're equal. So if array at mid, so the current value we're looking at is the same as val, then we could just return mid, right? We're done, we found it, we're good. All right, otherwise, we have an else if. So what condition do we want to think of next? So what should we do if, I don't know, array.mid, so is greater than the val? What do we want to do in this case? Yeah. Set which one? Set low equals to, yeah. Yeah, so in this case, let's see, the mid value is the value we got in the middle of the array. Let's say, for example, our array is just like, I don't know, 0, 1, and 2. And if we look at the middle element, we're looking for 2. Well, the mid element is 1. 1 is not greater than val, so it's on the left, or it's on the right side, right? So if we want to adjust it, how do I want to adjust it? Do I want to adjust low or high? Yeah. Yeah, adjust high. What should high be equal to? Equals mid? Mid minus 1, yeah. So mid minus 1, because I just checked this element, I don't have to check the other one. And then the nice thing about this is the other case is just, we know it's on the left half of the array, so it should be equal to mid plus 1, right? So if we compile and run that, we can go ahead and test it out. There's some code here that, again, uses qsort to sort that whole array, prints it off, and then does binary search that we just wrote to try and find it. So let's try and do binary search, looking for the value 6. And in this case, it says it is not found, so we have messed up.
You didn't put the case for like while it's running?
Oh, right, we didn't put the case in. That's a good point. So yeah, in this case, we forgot to put in the conditional for the while loop. Probably was a bad thing to not write in. So yeah, we have to write this conditional. What's our stopping condition going to be? When high is equal to low. So while high does not equal low then. Everyone like that condition? All right, so let's do that, compile it. Hopefully we find 6. It says found at index 4, 0, 1, 2, 3, 4. All right, so seems to work. Anyone have any arguments with that? Yeah. Yeah, can it maybe go out of bounds? Could it maybe go out of bounds? We're on the right track. So let's say, a few test cases we can see. Let's search for the value 0. It should say not found. It's not in there. Compile, run it. Probably doesn't take this long to search for it, right? Yeah. Sorry?
Have a smaller value than
Yeah, so we can print out what's happening here. So in this case, right, it should just immediately return not found, right? Should just immediately return not found. But if we go ahead and, I guess I don't have the debugger set, but if we have, low, high, oops, we're printing off the values, low and high. We can see with just that as our condition doesn't quite work because, yeah, we got high equals to -1. Like kind of exactly what you were saying, right? So, what is the condition I should put in there? Because low can equals high. Yeah, so what we want to do is we want to do this while high is greater than low, right? If it's not greater than low, it's the same element, something we've already checked already, or we don't have to do anything, it's kind of out of bounds. So if we do that, hey, we can see now it went low as high, it went through, checked it, it would get one value, so that's all the value we need, just needed to check it, and then we break out of the loop whenever high is greater than low, boom, we're done, it successfully says not found. All right, cool. Any other questions about that? All right, well, let's pose another question for you. So let's say in our array here, let's see, what do we have in here? So in our array, what about if I just add a whole bunch of 3s? So I add a whole bunch of 3s, and let's say I'm looking for the value 3. Let's not print off what index we got. Return 0. So I have something like this, where I have a whole bunch of 3s. So it starts at index 1 and goes up to, well, there's 1, 2, 3, 4, 5, 6, 7, 8. So any number between 1 and 8 would be valid, right? So if I run this right now, what index am I going to get out of this? Sorry? So if I search this array right now, this one with a whole bunch of 3s, and I just call binary search on it, what index is it going to tell me it found? So it's any number between 1 and 8. But the middle one of that, like the middle one of all the 3s? All right, well, let's try it. So the middle one of all the 3s, whoops. Compile, right again. Yeah, it says it found it at index 4. So 0, 1, 2, 3, 4. So is that one the middle of all the 3s? Kind of, yeah, kind of looks like it. But that might not be what you want, right? It's essentially whatever middle number it ended up that it found it on first and it returns. So if I want to tweak this a little bit, still use binary search, but I want to find the occurrence of the first 3. How would I do that? So how would I tweak this so that I find the first occurrence of the number? Yeah. So by only using binary search. So the solution, if you didn't hear it, is yeah, we use binary search to find any index of 3, and then we just go backwards one by one until we find out the first 3, right? Let's say we didn't want to do that. Let's say we wanted to binary search all the way to the first 3, because that might be slow if there's like 10 million of them or something, right? So, yeah. It's greater than or equal to val? So if we change this to greater than or equal to val, will this do anything? Yeah. Yeah. If I do greater than or equal to, it's not going to matter because the first if checks if it's equal, and it'll just stop there, right? So that won't quite do it. Any other thoughts? Yeah.
Instead of returning right away, you can store the index in a variable and continue to do binary search until you find the last one, like until I is less than index.
So we could create a variable called int found or something like that. And we want to just instead in here do found equals mid. And that's it. And just return found at the end.
No, but then search lower. So make under that make low is equal to array length minus mid minus 1.
Low is equal to mid.
No, where array mid equals value.
Uh-huh.
Right, we make the high variable equal to mid minus 1.
So that. All right, well, let's see. Let's run this and see. Grounded index 1. Seems to be kind of okay, except it will never end early, right? It'll have to go until it's at one element. So we could do a little bit better than this, but yeah, this does work. I would say this is perfectly valid. What about if I want to just immediately return as soon as I know that I found the first index? Yeah. Yeah. So yeah, this could go out of bounds. It's a little scary. We can compile, try that. It seems to work, at least in this case. Yeah, it could go out of bounds. How would I make sure that this never goes out of bounds? So if mid equals 0, yeah, so if mid equals 0, or, which means the index is the first index, it means it's the first index, I've searched all the way there, or if the value to the left one slot is lower than me, and I know if I'm in here that the current value is equal to me, so the next one over is lower, or I'm the first one, then I know I've checked the first occurrence of it, right? So then I'm good. Otherwise, if it is the current number and the one is also equal to me, I should also put an else in here as well, right? Because it could be the case that, hey, well, the current value or the current mid value is equal to the value I'm looking for, but the element to the left of me is also equal to my value. So I need to adjust high to be equal to low, or to be equal to mid minus 1 as well. So I would do something like that. That would cover all my cases. I'll go up, make sure we don't have any weird errors. Oh, whoops. So now we can change this back to return -1, compile. And we can see now it does work, and we did cover all of the cases now. right? So that doesn't change my binary search or anything like that. I'm just making sure that the first element is actually, that the value I found is actually the first element. I just have to modify my if statement a bit. So I could modify it so that I do something like this. So this is the example on the slide. If I just want to condense everything, I could just check, hey, if mid is currently equal to 0, or the value I'm looking for is greater than mid minus 1, and the value is equal to what at mid is currently the value I'm looking for, then I know this is for sure the first element, and then I don't have to have a nested if or anything like that that makes sure I adjust the low and high. I can just do something like that. Everyone all right with that? And the other one? All right, what about the recursive one? We immediately had the suggestion to write recursively. So if I want to write recursively, what do? So always with recursion, right? There's a base case, and then there's our recursive step. Recursive. So what's our base case here? If high is less than low, then return -1. Okay, and then is that the only base case we need? Yeah, so we have to find the mid again, so low plus high. Divide 2, yep.
And then if
array mid is equal to the value I'm looking for, then just return mid, right? Oops, which is also kind of my base case. And then my recursive step is, if that doesn't happen there's only 2 cases, right? So if val is greater than array of mid, if I want to write it in this order instead, then which direction do I need to search? Yeah, I have to search, in this case, I have to search the right side. So if I'm searching the right side and I wrote a recursive helper that, again, took the array and took low and high, well, I'm switching low, right? I'm adjusting low equal to mid plus 1 if I'm looking at the right half of the array. I'm leaving high alone, and I'm not touching the val because we're searching for the same thing. Otherwise, I know it's in the left half of the array, so I can leave low alone and then adjust high to be equal to mid minus 1. So I could also do that as well. That also works. In this case, it's probably might be a little bit shorter and easier to understand than, they're about the same length. So the iterative and recursive case, generally the same thing. Yep. Yep. Yeah, so this would be the exact same as the first case, where it just kind of prints a random first number found. But we could tweak this, that again, we could change the base case to make sure that this is the first occurrence of the number, just like before. All right, any questions about this? Lots of fun, lots of recursion. Yeah, your final questions are not quite finalized, but almost there. Yeah, recursion. I would make sure you understand it. But since recursion was the first thing you went for, I have high hopes everyone will do well. All right, so how about a slightly trickier one? So how would I modify this if I want to get the last occurrence? So I want the index of the last occurrence if there are multiple instead of the first. So in this case, it should be found at index 8 and not 1. Yeah. So if mid equals array length minus 1, array at mid is less than array at mid plus 1. Okay, yeah, plus 1 is less than array at mid. So same idea as before. Anything else I need to do? Yeah, we need to be searching up instead of down, right? So we need to do low equals mid plus 1. All right, does that look all right? All right, let's run it. Give you a second to look at that. So let me try and make it all fit. We need to change I? High? What, we need to change high again here? So high is equal to what? To the last value? So it's not high in this case. It's something a little bit more subtle. Yeah. What about mid plus 1 is what? If it's equal to the value and not array at mid, this one? Yeah. If it wasn't, then it should, if it's not, then it should be the next one over, right? We should go into the else, and it should be on the left half of the array. Yeah. So you sorry, what line do you want me to change? 28. What? Like you just want me to do that? All right, we can do that. Compile it, run that. Not. Can you print out all the high and low? Sure. Low, high, low, high. Oops. Print F. Print out mid. Oops. What did I do? Yeah.
The vowel taken plus I is greater than
This. So change that. Yay. So yeah, they can be equal, right? So we can make sure to test that value. Yeah, one way to do that, subtle little bug. If I had my code, let's say, if I tried to modify it that I did something here, actually, let me hide something real quick. Okay, so say I tried this, where I tried to fit it all in a single if statement. So I have an if statement that says, hey, if mid is equal to the last element, or if the value is less than mid plus 1, and, well, the current mid is equal to that value we're looking for, then return mid. And then I just do that, otherwise I just adjust low and high. If I go ahead and just run this and see in the while loop, my condition is low can be equal to high. If I compile this and I run this, and it's called binary search last, well, oops, let's say go here, add a whole bunch of 3s. If I do something like this, it says it found it at index 11. Oh wait, let's search for 3, my bad. So if we do this, it'll say not found. I just don't have the not found message printing, but in this case it returned -1. The bug in this case, when I made things a whole lot shorter, is a lot more subtle, because in this case, well, if it's not the last value, this will only be true if it goes into the last value and the current value is equal to it. But if the value is, if this doesn't happen and the value is equal to the current element I look at, well, I want to do what I did before and look at the right half of the array. So the case where val is equal to mid and this condition doesn't hold goes into here, and it would adjust this such that we look at the left half of the array instead. So this little subtle bug is I just need this, because I need to, if it's equal and I'm looking for the highest one, I want to look at the other half of the array. I want to look at the right half of the array. So if I compile this and run it, I can see it works properly now. Again, subtle little bugs that might trip you up depending on how you write things. So you have to be very, very, very careful. So again, like with most things, conceptually kind of easy. Once you try to program it, the nitty-gritty details, it could get a bit tricky. So that is the last index, and now that we have both of them, well, we can do something fun. If we wanted to actually write a function, whoops, sorry. So if we want to write a binary search function that purely used binary searches and found how many elements we have, well, we just wrote binary search first and binary search last, and they don't use any linear searching. They'll cut it in half every single time. So what I could do is use both of them. So I could call binary search first, get the first occurrence. If it's -1, then I know that number is not in the array. Otherwise, if I want to actually know the number of occurrences, I don't have to actually, linearly try to count all of them. I can just use binary search last, which will cut them in half every single time, getting rid of that linear search. And then the number of matches I know, it's just the first index minus, the last index minus the first index plus 1, because, well, we're counting in this case. So I can say, hey, we found that many matches. So if I combine them, I now have a very efficient algorithm for telling me the number of occurrences of some value in a sorted array. So in this case, if I search it with 8, I'll see that, hey, 2 matches. If I just populate it with a whole lot of 8s, so 8 and 8 and 8 and 8 and 8 and 8 and 8, even if there was a million 8s, it would cut the problem down in half every single time. So I wouldn't have to do, you know, that many, I wouldn't have to do millions of operations. It could just binary search binary search the first occurrence, binary search the last occurrence, and then I know how many matches there are. So in this case, I can see I added a whole bunch more. I got 10 matches. All right, any questions about that? Cool. So in the last half, or in the last 10 minutes, public service announcement. So your course evaluations are fillable. Please take this time now to fill them up. If you log in on Quarkus, it should pop up and ask you for course evaluations. They are very important, believe it or not. I only have a 13% response rate right now. Hopefully it can go up. But my pay is directly tied to what you write and how nice you are. So if you would like me to teach future courses and also, you know, keep me fed, please fill them out. And I do read all of them if you have any suggestions or anything, because this year was a whole overhaul of all the infrastructure to submit code and everything too, because before it was like just submit a zip file to a random server or something like that. So hopefully that is a lot more helpful. So please fill it in now, fill it out for the rest of your courses, because again, yes, all professors' salary are somewhat tied to that. And I like getting paid and I like teaching, so I would like to teach again, especially since I'm up for a review very shortly. So if you want to see me again in 3rd year, please fill them out and hopefully be nice. So with that, I will stick around. Hopefully you can fill them out. So just remember,